In this video, we'll be talking about Biot Savart law. We'll be learning this key concept from magnetism, and I'll skip the basic derivation of Biot Savart law application for magnetic field in a current carrying wire. But what I'll focus on the problem solving using the key definition. So let's start with what is Biot Savart law. The definition. So it says that if I have a current carrying conductor and it has a current magnitude I, then the differential magnetic field, the small magnetic field that is produced by any differential length dl at a point P, that is at a distance r, is given by nu naught upon 4 pi I and the cross product dl cross r divided by r magnitude cube. So that becomes basically nu naught I dl sine theta upon 4 pi r square, where the theta is the angle between the differential length and the radius vector. So this magnitude is the result of the cross product of dl cross r. So dl cross r will give you the direction of dB. So as we can see, if the point P is in the right direction, then dl cross r we are going clockwise, and the magnetic field at P will be in cross direction, that's going into the plane. And if I'm calculating at any point that is left uh, of the wire, let's say the point P is on the left, then I'll do dl cross r, and that will go anti-clockwise, and the field will be coming out of the plane, that means dot. So using this law, we can easily derive this magnetic field due to a current carrying wire of finite length. So I'm saying that the magnetic field, the wire is AB, and I have to calculate the magnetic field at a point O, that is at a perpendicular distance D from the wire. And let's say the end A is making angle theta 1 and end B is making angle theta 2. Then we have this formula B net is equal to, that B net is net magnetic field because of this wire, is equal to nu naught I upon 4 pi d sine theta 1 plus sine theta 2. So this derivation you can easily find in any of the textbooks given as +2 level. So what I will focus on using this formula, this Biot Savart law application, this result I'll be using to solve a couple of formulas problems to see how it goes. Okay. So here are a few problems where you have to calculate the B net and the direction. The first is a square of length A. The current is going clockwise direction. Value of the current is I. In the second one, it's a equilateral triangle, and the current is going anti-clockwise. The value of the current is I. And the length in each case, the side length is A, and here the side length is A. And here we have a circular loop, and the current is I, and let's say the radius is R. So I have to calculate the net magnetic field at O in each of the following cases. So let's calculate. Let's start with the first case, the square one. So what I have is a square, and all I know that is the current value is I. Okay, and the current sense is going clockwise direction, and I have to calculate the magnetic field at O. Now if you see the magnetic field due to this segment, this AB, let's name this A B C D, the magnetic field due to this AB length is going into the plane, that is the sense of the magnetic field is cross, and the magnetic field direction due to this BC wire is again cross, and again due to CD wire is cross, and DA wire is cross again. So at first you might think that the net magnetic field at O will be 0, but that's not the case. As you see, the at in the right direction, in the rightwards direction, the magnetic field is always cross, because using the thumb rule of magnetic field, if your thumb is in the direction of the current, and then the magnetic field form closed loops, and they go anti-clockwise direction if the thumb is pointing upwards. So it anti-clockwise direction, this will go into the magnetic field of lines and coming out of the plane from this side. So the magnetic field direction is cross because of all these arms. So if I can calculate, if I can calculate the magnetic field to one wire, then the net magnetic field will be equal to the 4 times magnetic field to a one wire. So let's calculate. I can calculate B due to AB, and let's say that is X. Then B net will be 4 times this B due to AB. So let's calculate B due to AB. So we just learned that formula, that B due to a finite wire is equal to nu naught I upon 4 pi d sine alpha plus sine beta, where the alpha and beta angles were the angle made this way. If I'm talking about this, that becomes cos, not a big deal. And this is the distance of the point, perpendicular distance of the point from the wire. So the perpendicular distance of the point from the wire is basically, if I'm saying the this length is a, then this is basically a by 2. So this d becomes a by 2. And if you look close enough, then this angle is 90, this whole angle is 90 degree, then each of the angle is 45 degree and 45 degree. Then alpha is equal to 45 degree, beta is equal to 45 degree. So sine alpha plus sine beta is becomes 1 by root 2 plus 1 by root 2, that is root 2. So BAB, let's calculate BAB. So BAB becomes nu naught I upon 4 pi d sin alpha plus sin beta, that becomes root 2. And putting the value of d, that is a by root 2, we get nu naught I upon 4 pi a by root 2 goes up, so this becomes a and this becomes 2 root 2. So BAB is nu naught I upon 4 pi a 2 root 2. So if I'm calculating the net magnetic field, that's just the 4 times this BAB. So B net becomes 4 into nu naught I 2 root 2 divided by 4 pi a, and that becomes 4 and 4 get cancel out, so that becomes 2 root 2 nu naught I upon pi a. So this is your answer for the first case. So now we have to calculate the B net due to this current carrying triangular equilateral wire. So I'm saying that we have to find this B net at this point O. Now we can definitely say that this is a symmetrical case, and B at O, the net magnetic field, will be 3 times the B due to one wire, that let's say that is AB. So if I calculate the B due to AB, that is one arm, then I can calculate the multiplying by 3 times, and we can calculate the B net. So let's calculate BAB. Going by the definition, simply nu naught I upon 4 pi d sine alpha plus sine beta, and here you can say that this angle will be 30 degree and this angle will be 60 degree. As you can see here, I have already made that for you. This angle is 30 degree, this angle is 60 degrees, so I'm doing sine 60 plus sine 60, that is root 3 by 2 plus root 3 by 2, and that is 2 root 3 by 2, that is equal to root 3. So that becomes basically nu naught I upon 4 pi d into root 3. Now I have this done here. This d distance will be a by 2 root 3. So as you can see in this triangle AOP, tan 30 will be d by a by root 2, that means 1 by root 3 is equal to 2d by a, that means d is equal to a by 2 root 3. I'll just plug in the value, and nu naught I upon 4 pi d is equal to a by 2 root 3, and we already had this root 3, so this becomes 3 into 2 into nu naught I upon 4 pi a. So this, simplifying this, 3 by 2 nu naught I upon pi a. So this B net, as we saw earlier, this B net will be 3 times the B of this single value. So I'll just multiply by 3, that becomes 9 by 2 nu naught I upon 2 pi a. This is the net magnetic field at O because of this loop.